When your gadgets are down and your lights won't glow, you got a problem and it's starting to show. But don't you fret, don't let it get you down. 12-volt Vids is the name that's going round. With a wrench and a smile, they'll fix your despair, bringing life back to your gear, fixing everything with flair. 12-volt Vids, they're the ones to call, bringing power and joy, they'll fix it all. Every wire in place, every bolt tightened right, they're the rock stars of repair, shining bright in the night.
This is the Sony SLHFR70. That's a Super Betamax that was not initially hi-fi, but it was hi-fi ready, and with the optional processor, which is with it underneath it here, it is fully hi-fi. Now, the reason I'm going to look at this processor is the fellow that brought me this, he just bought it, and it looks like somebody may have been into this and they forgot to put the screws in to hold the audio outputs in place. So I'm just going to dig up a couple screws for that, and then we'll get into this unit here and see what's wrong with it. It has a playback problem. It plays for a few seconds and cuts out. I don't have any bolts with nuts, so I'm just going to use some regular screws and use drywall anchors to anchor them into to hold the jack panel in place. Probably could have used longer screws, but these will hold it in place. And that should provide enough strain relief there so that the jack panel won't push through when he tries to plug things in. Okay, that's taking care of that problem. We'll get a look at this board before I put it together, because I think it's probably okay, but we'll get a look at it anyway because I think these are pretty cool. We've got a DBX chip over here for MTS stereo TV decoding. Yes, this is the MTS decoder. So how it worked is the baseband audio from the beta machine, the beta recorder, fed the baseband audio into here, where it went to, I believe this was the decoder board here. This was the MTS decoder, and this was the DBX, because they used 2 times compression, DBX compression. And this is a stereo chip, but we only need it for 1 channel because they only compressed the different signal. So think of TV stereo like FM stereo. You have your baseband audio that goes from 0 to basically 16 kilohertz for FM. For TV, it's a little less than 15 kilohertz for your baseband audio. There's a pilot tone. FM had to drop off at just over 15 kilohertz because there could be no high frequency content at 19 kilohertz where the sub-audible or subcarrier pilot carrier was, pilot tone that was used to synchronize the decoder. On TV, they can synchronize to the horizontal frequency because of the mathematics involved. I think it was 4 times the horizontal frequency. I think that's what it was, as that says here. Yep, VCO 4H, so 4 times horizontal. There should be another one in here for VCO 5 times as well on here. Anyway, how it worked. Your baseband audio was mono, and then at a carrier 4 times the horizontal frequency, a subcarrier at 4 times the horizontal frequency, 15.57 I think kilohertz. There was a subcarrier that contained the stereo information as a double sideband suppressed carrier baseband multiplexed audio, and that was the left minus right information that was sent on that subchannel. They used DBX noise reduction, so they compressed the signal on the subcarrier only, not the mono baseband audio that was received by all the regular TVs, and that's where the main audio was. Only on the stereo different signal they used 2 times compression because it improved the signal to noise ratio. Now, had this been invented before FM stereo became the standard. It may have been even used on that. They tried it with Dolby FM, but Dolby FM didn't really go anywhere. DBX FM may have gone somewhere had it been around from the beginning, because the subcarrier, the different signal, is the one that gets noisy. That's why when you're listening to an FM broadcast and the signal's a little bit weak, you hear all the static and you turn off the stereo and listen to it in mono because there's just too much noise on the stereo. Well, that's because the subcarrier, being higher in frequency and being amplitude modulated with a suppressed carrier, is more likely to pick up noise. So on the TV standard, when they developed it, they said let's put noise reduction on that noisy channel to improve the sound, and they did it using DBX, and that's why there's a DBX chip here. This is the same DBX chip that was used on tape decks that had DBX. Every stereo television, every stereo VCR had to have a DBX chip in it. When you think about it, DBX did very well as the standard for MTS television sound, or multi-channel TV sound. That's what MTS stands for. Every TV, they had to pay a royalty to a DBX corporation for use of the chip. That's one of the reasons why when you had modulators, like they didn't put stereo modulators in the VCRs to send out the signal on channel 3 as a stereo signal for your TV. It was only a mono signal. That's why most modulators that you bought, with the exception of some high-end ones, I think Radio Shack had one. I know Radio Shack had one because I've got one. That was MTS. But they were much more expensive because they had to license the technology from DBX. And from what I understand, the DBX had an agreement with the manufacturers of the TVs and equipment that had the DBX chip in for receiving, that they got a special rate. But if it was used as a modulator, for example, they had to pay a different rate. It's a stereo chip, and you wonder why do we need a stereo chip? We're only using one channel. But aha! Not only was the stereo different signal, the left minus right signal, compressed with DBX, but also the second audio program. So for second languages such as Spanish or French, or reading service for the blind, descriptive video is what it's also known as, they had that on the second or the third channel, I should say, because the first channel is your primary FM mono audio for the main TV sound. The second was the stereo different signal, the left minus right, which was DBX companded, and that was for your stereo televisions. And the third was the SAP, or second audio program, and it was also compressed with DBX, and that was fed through here. What the VCR had the capability of doing was, if you had SAP turned on the button on the front here, what that would do is that would record the stereo signal on the hi-fi audio track, and it would record the SAP channel on the linear track, so you could record both the SAP content and hi-fi stereo. And then in that case, you're using both channels of the DBX decoder. One to expand the sound for the MTS second channel, and the other one for the SAP channel. And there was actually another channel that was available called the professional channel, and that was used by some TV stations. No consumer receiver had it, but there were receivers that were available to broadcasters where the broadcaster could put the professional channel, which was basically the IFB intercom channel from the TV station, that was broadcast out so that reporters in the field that were doing live spots, they could hear the director and respond. So the director could talk to them and say, hey, you're up in 5 seconds. Okay, 4-3 cue, right? That was transmitted out the main TV transmitter, and the crew out in the field, because they were able to receive the signal, obviously, in their truck, so they could see what was going on. The guy working in the truck that was, working the camera and working the transmitter uplink to the TV station, he could hear what was going on at the station coming back. It just saved them having to have, well, now they would do it all with cell phones, but this is going back in the day before they had cell phones in the trucks. A lot of them had two-way radios. This saved their two-way radio channel so they could use it as a two-way radio as opposed to just a backhaul from the station. The station could talk to them over the professional channel. And some people would modify their TVs and change the frequency There was a frequency adjustment, and you could turn the frequency up from 5 horizontal to, I think it was 7, because it was 4 times for the MTS channel, 5 times for the SAP, and it was either 6 or 7 times horizontal that was used for the professional channel. But you could tune it in if the station did it. Not every market did, but a lot of the big markets where they did a lot of live stuff with microwave live. This is before they were doing cell phone stuff. Now they don't do any of that. Now they don't have microwave trucks anymore. They don't have satellite trucks that much anymore either, because now all the live stuff is just done over cellular. But anyway, that was that. This side over here, this is the power supply, obviously. This side over here, this is the side that does all the processing for FM recording onto the tape and filtering and so forth, where the additional 4 carriers, 2 per head for left and right, are added and sent back, and then it goes into the recording amplifier and it's recorded on tape. And on playback, the RF coming out of the preamp is sent down to here, where it is decoded for audio. But the video part of it stays inside the VCR. It's just a second tap. So basically, this is just going to insert the carrier to the existing one. The RF is generated for the hi-fi carriers here, sent to the VCR, and on playback it receives it back from the VCR and it decodes it. You have line in and line out, and then on here you can select auto stereo, MPX filter, and you can see there's inputs on here. You could record line audio. If you wanted to record audio only and use your beta machine as a high quality audio recorder, you could select audio only and line audio. And then it would actually turn off the video portion. And then you didn't have to have your VCR connected to a source of sync, because the rotation of the head is synchronized to incoming sync. But if you're using this as an audio recorder, there was no sync. So by switching it to audio only, this is generating a signal that simulates a video signal going back to the VCR, so that the head drum can be synchronized, and then it can be used to record audio only. That's this. We've got this back together. I'm going to throw this together. We're going to grab the machine that has a fault and continue with that one. All right, first things first, let's see what it does. No picture, just snow. Let's pull the top. All right, let's load the tape again. That looks fine. We'll clean the heads first, see if that improves anything. Didn't look like they were dirty. The drum isn't even spinning. We have a drum drive problem on this one. Okay. Hall effects on the drum itself. We're hearing sound just from the linear, right? But yeah, see, that's supposed to spin, but it's not. Let's pull this apart. I'll dump the hi-fi processor. I plugged it in, but we don't need that plugged in for now. We need to deal with getting the drum speed up to the proper speed. On these units, one of the places that we find problems is the Hall effect sensor, which is right down here, which we can't see because the rotor is in place on top of it. But if I pop the rotor out, we're going to look and see if there's any corrosion on this, because they put glue, they put that crap glue on there, and it got corrosive and conductive. All right, now I got to lift this up carefully. There we go. Now we got to place this somewhere where magnetic material is not going to get stuck to it. So I'm going to put it over on the power supply over here. Just set it up here out of the way. It'll stick there. This is what I'm working on. Usually what goes wrong. As you'll see down here, looks like there's dried glue. This one's actually not too bad considering some of them are just rotten, but we're going to try to scrape that away because that glue that's in there goes conductive. You'll notice that the Hall effect device has 4 leads on it. Power, ground, and 2 outputs. That's so that it can sense not only the speed, but the direction. So if the Hall effect device is not working, the motor will not spin, or will not spin the correct speed. Alright, let's plug it back into the TV, and we'll see whether I get anything on it now. Nope, still not spinning the right speed. And if I stop it, it'll well, at least it's starting on its own. Well, it's actually not, but it's spinning way too slow. The next thing I'm going to do is I'm going to unplug the drum motor, and we're going to remove the drum itself. I need to do an inspection on it. Got the cables unplugged from the bottom. We're going to pull out this guide. I guess they call them the V-stopper blocks for the guides. We'll remove that because I want to pull the drum out. I want to separate the motor from the head drum itself so I can inspect it because the drive IC is on the motor itself. Remove the screws that hold the drum in place and lift the drum out from the top, and then I can split the drum from the motor. Now I can lift the drum out and we can check out the actual electronics on the drum itself. So to do that again, I got to remove the rotor. So we'll take the rotor off again. Next I'll separate the actual coil pack from the rest of the drum. And then set the drum aside, set the video heads aside, I should say, so they're not going to get damaged. So we'll just pop this off. Keep in mind where the heads are, so I don't touch around it, and then just pop this piece off. Yeah, they put glue on it. Okay, I got one wire I got to take out from here. They put glue on it because you were supposed to replace the entire lower drum to change the motor. So on here we've got the 3 coils because it's a 3-head machine with special effect head. And we've got the PG pulse generators over here that detect what position the head drum is in. And that gets sent back to the servo. Set that aside. The circuitry I'm interested in is these ones here. It could be this frequency, the frequency generator, the Hall effect device. They cause a lot of problems with the heads not rotating. That's usually what goes wrong, is the Hall effect device here goes bad. So I took the Hall effect chip out of there so that I could scrape out any remnants of the old glue that's on here, because that glue goes conductive. So just making contact with the back of the wires there is enough to cause leakage and cause it to be misread. And that's usually what goes wrong on these units. We were finding this problem out 40 years ago. When these machines were common, we used to have to change a lot of these. Used to be able to get the part separate and change it. Because something had come in and they were corroded and the leads were snapped off right where they went into the chip. This one they're not snapped, so maybe it's okay, maybe it's not, but this is the most likely culprit. If I had another one of these kicking around, I might have one, but I could just swap the whole motor assembly. I'm putting the Hall sensor back in now. I cleaned all the crap that was inside the old dried up glue that had kind of turned brown and crusty. That's usually what causes these to fail. So I say sometimes the chip itself fails, but it's usually the glue. So we'll reassemble the drum, reinstall it, and see whether it rotates. And for those of you wondering about the caps, they're 1 microfarad. They test fine on ESR. They're well within the spec for ESR. I don't think I've ever seen those caps fail on these machines. Say 9 times out of 10 it's either the IC has gone bad, or usually it's the Hall effect chip. It's not able to read the pulses and it doesn't get it. Because what happens when the drum starts to rotate is it starts to produce a signal which tells the circuitry that the drum has rotated, and then it tells it to switch. It's basically 2 phases on here. You've got there's 3 coils that are connected in series, and there's 2 phases, and it just cycles between the 2 of them to make the drum rotate. That creates the moving magnetic field. One thing I do need to make sure is that the actual rotor doesn't touch the Hall effect. It is not touching, because we don't want it to touch, otherwise it'll just wear it out. Alright, drum is plugged back in. Is it going to spin or not? Let's see here. Nope. It's not going to spin. Therefore, if it's not going to spin, I'm not going to get a picture. Damn it. If we look at the voltage on the meter, this is the servo voltage. It's trying to tell the drum to speed up. If I press stop, that'll go down to 0, so the drum shuts off. So it's calling for the drum to spin. I can feel the torque on the drum, like there's nothing now, you see, but if I try to run it, it'll actually lock up. Here's a drum I already pulled it before because I robbed the heads out of this to fix another one. Here's a good example of the PG sensors, right? There's magnets on the bottom of the head disc that pass over these coils, which provide the PG pulses to synchronize the switching. The motor on this, I don't know if it works or not. I guess we'll find out. I'll pop this one apart. We'll swap the motor coil assembly and see whether that will make this one work. Gotta break this free first. They are tight. This one's never been apart, so that's a good sign. What I'll do is I'll pop the screws out on the rotor assembly first. Okay, there's the new rotor assembly, motor and rotor. Hopefully the Hall effect is okay on this one. a look at the heads here before I put it back together. That's the two heads there. That's the special effect head, and that's the B head. So the other one's the A plus B. So we rotate it so that the heads are not in a position where I'm going to touch them while I'm working on it. I hang onto the drum, basically like that. So I've got the heads positioned so that they're here and here, and when I handle the drum, I handle it like that. That way I don't have to worry about touching the heads while I'm reinstalling the drum. Bring the chassis back and widen the camera up a bit and put the wires through. Alright, now I can test it out and see whether the motor spins. Unless this drum is also bad, which, I mean, it could be. I don't remember what was wrong with that machine that the heads were pulled out of. I know I pulled the STK 54, or whatever it was, 51, whatever the STK is on this. What is it? It's a 5441. I know I pulled that out of the donor machine that this came, the lower drum or the motor came from. I pulled that to fix one of my SLHF7000s before, and the head disc was pulled for something else. So now the motor's been pulled. Is it going to turn? Of course it's going to turn. And I'm going to get a picture. Let's plug the monitor in. And we have a picture. It's not set properly yet. I got to do alignment on it now because I had the head drum out, but we got a picture. We didn't have one before. Oh, that's plasma interference for sure. It's causing that. Maybe the head clogged up a little bit too. That's always a possibility. Yeah, maybe the head clogged up. Where's my tracking control on this one? Tracking control. Yeah, see, tracking's off, so I got to do an alignment. But the machine's playing, which is all that matters. So let's get the machine back together. I'll hook up the hi-fi processor, we'll put the scope on it and do an alignment of the tape path. The alignment's a little bit off. I'm going to adjust the exit guide. I'll show you the guide I'm going to adjust, and then I'll put the camera back on the scope. That's the one I'm going to adjust. That one right there. Okay, adjusting it now. There we go. Much better. Now this is not the alignment tape that I'm using. I'm just using an old tape on here. I'll throw the alignment tape on. We'll take a look at that. Okay, there's the factory alignment tape. We're only look at one head because one head doesn't have signal on it. That is almost perfect. Could I make it better? Yeah, I don't know about that. It's looking pretty flat. That's what we want to see on all these machines. For the two guides I adjusted, the entrance side is this one here. It's just a nut. You adjust it with a little nut driver or a pair of pliers, and that's the entrance side guide. And the exit side guide is this one that I showed you before down here. For you guys that absolutely need to know where the test points are, they're right here on the back side of the RF preamp. I had to turn the plasma TV off just so I didn't get interference while I was doing this. The pins we connect to, this one here is the trigger, is the RF, and that one is the trigger. They're connected to, starting from this side, the side closest to the front. That first pin closest to the front is the switch point. Then there's a ground, and then the next one over is RF, and then another ground. So that first one is your test point, and the third one over here, that's the RF. There's just the two screws that hold the board in place, but the front panel has to come off, otherwise you're not flipping the board up. So I'm going to throw the front cover back on it now. Whoops. Might help if I have the right screwdriver. And then we're going to hook this thing up with that hi-fi processor and make sure that that is working. And maybe play around with it a bit. Maybe record some stuff. And there it is playing. Beta Hi-Fi. The mono sound for this would come out of the machine itself. It doesn't, I don't think it switches that. It just does it this way. Anyway, it's playing Hi-Fi. I'm going to grab a tape that I can record on. I'll put this in audio only mode, and we'll record some stuff onto a blank tape basically, and I'll show you how it works. It's an audio recorder, and then we'll look at the picture again on the other TV. Alright, I've got my music coming from my media player. We'll hit record. I'm recording color bars on here now, but I can turn the color bars off. It's an old tape. I'm in the beta 2 mode. Turn off the video. Now it's audio only. And now we'll see the picture on playback. Nice dropouts on this. And the picture should cut out any time now because I did hit audio only. There we go. And that's where I switched it to audio only on the, it's not in audio only now, but now it is. It's only for record. That was the end of the recording. I got bad tapes, I know. This tape's been used a lot. And it's been sitting around too for many years. There's where the audio, that's where the audio only was pressed on here. See, normally when it's running, if you press audio only, it'll fill the video. That's so you can record sound without having an input, right? Because otherwise you have to have an input. So that generates black. And the record's just black. Anyway, fingers crossed this is going to work. I'm going to throw my other tape in here, and I'm going to let this thing run for a while before I send it out. So here's the playback tape. I can't play the music off this because it's not royalty free, and for that matter, either is the video. Lounge V will have a connection. Well, this isn't Lounge V, this one, but this was just stuff I recorded off YouTube. But anyway, I'm going to let this one play, and I'm going to say this one's done. I just spent the entire day on this thing. So I had the unit playing for a couple of hours, and this motor is going bad. You can hear it. Maybe one of the coils is open, but yeah, it just started slowing down. So I guess this one we're gonna have to try to find another motor for it. I don't have any here I don't have any junk machines. Actually, I do have a junk machine here, but I don't know if the motor's any good on it. I think I already robbed it. Alright, so let's just test this out here. I've got the original drum, or not the original, I got the replacement drum plugged in. And as you can see, the motor spins. It's not spinning up to the right speed though, it's going slow like the other one was doing initially. It was spinning up to the right speed, but now it's going slow. If I unplug this one and plug this other motor in, you'll see this one here doesn't even attempt to spin. Press play, it just does that. I go back to the other one and it's trying to spin. It's the hall sensors. It's the hall sensor that's bad on the motor. Plug that one back in and that one spins. Yeah, it's the hall sensor. God damn. That's it. It's the hall sensor that always fails on this. Always, without fail, the hall sensor fails. It's a pretty simple analog circuit. You got a control voltage and 12 volts in ground. And you raise or lower that voltage. Smoothed by a capacitor here. And that's how you control the speed, is you increase the voltage to increase the speed, to decrease the voltage. Once it locks in, that voltage will remain stable, and it's now an error correction voltage. It'll change ever so slightly to keep the phase and the speed and the phase in check. Yeah, unfortunately, I don't have another motor for this, unfortunately. Okay, this is motor number 3. Will it spin? Nope. It's bad too. They're all bad. See? It won't spin.
From cars to the sounds that make you feel free. We're grateful for the love, you're the family. Late nights and bright lights, cruising the lane with every video drop. You're calling our name, so we sing it loud. Let the world hear our sound. Big thanks to you all for being around. Big thanks to you all for being around. Thank you for watching.